Hello. In this video, we will discuss the exit tickets slide for day 24 of your Desmos activity. So let's get started. We're going to try to use a different pen just to see how things work out. Right, so let's get started. We have day 24. Day 24. This is going to be slide 18. Slide 18. Box that up for record. Excellent. So the question is, large cheese pizza costs $5 each, and large one topping pizzas cost $6 each, which is, I would say, it's a good deal. Write an equation that represents the total cost T of C large cheese pizzas and D large one topping pizzas. So let's write down the information. So large cheese pizza and large one topping pizza. One topping pizza. Let's see. Large cheese pizza costs $5 each, and one topping costs $6 each. We're given what's the request? So write an expression, write an equation that represents the total cost T of C large cheese pizza and D large one topping. Ooh, handwriting is definitely improved. If you have some prior knowledge of the total cost being the sum of the subtotal of the two items order, and the relationship is multiplication, please move on to the next slide. Otherwise, stay with us. We're going to use the table method again just to prove a point. So again, let's do the table method. Let's do the table method. We have the cost for cheese pizza, cost for cheese, number of cheese, move on to the next one. We have the cost, sorry, not for, but per. Cost per one topping. We have number of one topping. And we have the total. We have the total. Think of different scenarios. So let's imagine if we want to have, what is it? Let's just say 1 in 10. Why not, right? Why not? Go with different scenarios. So if I want one large cheese pizza and 10 one toppings, the cost for each pizza is going to be $5 and $6 per pizza. We're not going to calculate the total yet. Actually, you know what? We're not going to calculate the total. And let's think of the reverse scenario. If we want 10 cheese pizza and 4 toppings, we can also calculate that. This is going to be $6 each. This is going to be $5 each. A different scenario, if I want 20 of each, so if I want 20 large cheese pizza and 21 toppings, the unit cost for each remains $6 the unit cost for each cheese pizza. Sorry, this is going to remain to be 5. And this trend will continue. If you're interested, you can calculate the total. Just for now, I'm going to write this out for you. So this is going to be 65. This is going to be 56. This is going to be, ooh, why did I do this? I think this is going to be 220. I think. Excellent. So following from the previous Desmos slides we did, if you observe over here going down the column, this remains the same. Remains the same. This one remains the same. And these three changes. To change. Or if you want to use a different vocabulary, you can say vary. So if these numbers continue, if these numbers were to continue, you can probably predict that if we were to just write out different scenarios, the number of pizzas ordered you can definitely change forever, but the unit price per pizza will remain the same. Good note. So let's go up. And so how do we do this? Let's write a variable. So we know that it doesn't matter what happens, the price per cheese pizza will remain at $5, and the price for large one topping will remain at $6. The number of cheese pizza ordered, and we actually have this. C is the number of large cheese pizza ordered, and D is the number of one topping pizza ordered. So this is going to be D. It's going to be C. Now we're just filling the tables. Oh, wait a minute. Oh, you can't see it? Well, follow it. I will modify a little bit, right? Let's see. How do we get this up here? There we go. See, we can do that. We can do that. If you want to go in depth and figure out the patterns between these, you'll realize the way I got 65 was I multiply these two numbers, $5 per one pizza, $6 per 10 pizza. Sorry. So $5 per pizza, I got 1. $6 per pizza, I got 10. And once I calculate the subtotal, I added the 2, right? So the difference between these two quantities are you sum them up and you multiply the price per pizza and the quantity order. And so you will do this, you will multiply these two, the same thing, and you will add, and you get the total to be what? T. And so if you just want to put like a simple answer on top, this would just be the total cost equals 5 multiplied by the amount of cheese pizza ordered C plus 6. That's the price for one topping pizza multiplied by D. That would be what you put into Desmos. Again, the space arrangement is a little different. I'm still modifying with things, but that will conclude slide 18 for this. That will conclude slide 18. Let me put a new one. Hold on just a sec. Thank you for your patience. Move this out. Move this in. The next slide of concern is slide 19 on day 24. So let's write that out. Let's write that out. This is day 24, slide 19. The question scenario is, Claire volunteered at a local library during the summer. Her work includes putting labels on 750 books. First question, how many minutes will she need to finish labeling all books if she takes no breaks and labels 10 books a minute? The second question is, How many minutes will she need to finish labeling all books if she takes no breaks and labels 15 books a minute? Let's go into it. So question one. It's question one. Question one. We have 750 books going through an internship. It's going to be processed at 10 books per minute. So going through, so if you think about it, I have a pile of 750 books. I'm sorry, I am not a good painter, so I can't draw 750 books for you. But let's just imagine we have 750 books. Each minute, I can label 10 books. Beep, go to the next one. Beep, go to the next one. There should be like a sticker sound. I don't have that, but you just label it, move on to the next one, label it, move on to the next one, label it, move on to the next one. So 750 books you can process. Clear can process, processing at 10 books a minute. How long will it take? Question mark. So if you want to just go down the scenario, you can definitely take 10 books off out of 750 each minute and see how many times you need to take 10 off to reach the target number 0. The faster way that you can think about this is how many times does 10 books goes into 750 books. And so you can do this by doing 750 books divided by 10 books per minute. Per minute, I should have written the per, but here we go. So if you want to do a little long division, we actually have space over here. So 750 divided by 10. If you want to go look down over here, it doesn't go into 7. It does go into 75, 7 times. So it's giving me 70, leaving me with 5. It doesn't go into 5, so it goes into 50. How many times? 5, giving me 50 with nothing left. So it will actually be over here. This is actually your answer. When you do a long division, that will be your answer. And so this will actually take 75 minutes. So this will be an answer for slide 24. Sorry, day 24, slide 19. Let's move on to the next question. It's very similar. So 750 books, processing it. Sorry, shorthand, don't write shorthand. 15 books per minute. How long will it take? Same question again. And so the same procedure will follow. Let's take a look and see what we have. So let's see if we can get the camera up a little bit. That's okay. Oh, you can't? It's okay. So you'll have, what's this? Oh, I lost my laptop. Sorry. So the same process continues. You have 750 books divided by 15 books per minute, giving me whatever we have. So let's think about it. So 750 divided by 15. So 15 doesn't go into 7. 15 does go into 75 5 times, giving me 75, leaving me with 0, 0. Answer is 50 minutes. And just as a fraction thing, if you want to go ahead and practice, right? If you multiply these two numbers together, it should give you 750. If you multiply these two numbers, it should give you 750. That's just the that would be a way to double check your work. So with that, that concludes our day 24, slide 19. We're going to move on to the next one, which is slide 20. Let's take a look. Ooh, next page. Yeah, here we go. And we're going to try with a different marker. And what is the question? Let's take a look. All right, perfect. So Elena has $225 in her bank account. She takes out $20 each week for a number of weeks. We label it W. After W weeks, she has D dollars left in her bank account. Write an equation that represents the amount of money left in her bank account after W weeks. Let's go. So this would be day 24, slide 20. Day 24, slide 20. Come on, focus, phone. Here we go. Good. So we have originally, we have $225 in the bank. Each week, we take out $20 for W weeks. After W weeks, we have D amount, D dollars left in bank. So the question is asking us to write an equation that represents this scenario using the variable D, the amount of dollars remaining in the bank, W for the amount of for how many weeks it's passed. And originally we have $225 in the bank account, in which we take out $20 per week. So let's give it a try. And we are going to, instead of jumping straight into variables, we're going to start again with the tables. Let's see. Original in bank. So original within bank, and then we have withdraw and number of weeks, and final bank remaining. Think about it, right? So originally we have $225 in the bank, and we're withdrawing $20 per week. Let's think about before we start. Well, actually, the first week before we start zero. That doesn't. We'll talk about it later in later slides. So after 1 week, the number for 1 week. So after 1 week, we took out $20 from 225, leaving us with let's take a look. If I have 225 and I took 20 out because we only have 1 week, that's 205 remaining. Let's look at the scenario for week 2. After week 2, I'm still going to take out $20 from the original bank account. Actually, you know what? It's week 2 compared to the original bank account savings. Original, we have 225 after week 2, we take out $20 twice, and so it will actually be, let's see, I think this is going to give me a total of 185. And then we can continue and see what happens after what happens after 3 weeks. The third week, compared to the original bank account, I'm going to take out $20 3 times, right, from the original account of 225. And so this is going to get me $20 less than week 2. So 165, and the number continues. An observation for this is from our learning from day 23 that this column seems to be the same. So let's write same. This column remains the same. So let's write the same. Now this, the number of week varies. Let's put vary. In the final week, they keep dropping by $20, going down. And so we're going to write vary. If we're to look at the question statement, so let's see, hold on. So after any amount of weeks, if you're just trying to magically pick out a row, and fill in the values, you can probably predict that 225 will remain the same. So I know that this record. So you realize that the $225 remains the same. The $20 remains the same. Now this thing varies. Within the question statement, let's see if we have anything representing the amount of weeks that's passed since the original $225 dollars. So let's read through that. So we have $225 in the bank. Each week we take out $25 and for W weeks. So the number of weeks, we're going to look at W. And we have D dollars left in the bank. So the final amount that we have within the bank, since it's vary, the question statement gives us a variable to define it. We'll write D. If you want to explore the relationship between all these roles, you'll realize that week 1, we basically took $20, which is $20 multiplied 1, and we took it out from 225. So within these two numbers, the relationships of multiplication, and to get to $205, to get to 205, which is our question, that's the question we're asking, you subtract 20 from 225, arriving at 205. The same thing. From the start, if we take 2 sets of 20 away from 225, we get 185. And the relationship continues. So if you follow the pattern, you can actually do this. So the final cost, the final unknown amount in the bank, we use the variable D to represent it because it varies. And how much money are we going to take out? It's going to be a function. It's going to be depending on how many weeks it's passed. Each week we take out $20, and this amount is going to be deducted from the original bank account. Amount is 225. So this will actually be the expression, the equation that you need to have for slide 1. So for slide 20 of Desmos day 24. Right? So D is the amount remaining in the bank. W is the week that's passed since we first withdraw money from the account. And 225 is the original amount within the bank. 20 just states that we're constantly withdrawing $20 from the bank each week. Again, so thanks for watching. This concludes day 24's exit ticket explanation. Until next time, please stay safe. Go Knights!